Okay, so this video is all about components and conventions. In your GCSE, you need to be able to recognise and draw some common circuit symbols. Today we're going to go through a few ones, but make sure to check your own spec for an exhaustive list. So here they are, and with a few hints to help you remember them. First up, we have got our ammeter, our voltmeter, and our motor. And if you ever needed evidence that physicists are lazy, here it is. Your ammeter, which measures current, is a circle with an A. Your voltmeter, measuring voltage, is a circle with a V. And your motor, which spins, is a circle with an M. Sort of inadvertently got the sound of a motor in the background. Okay, and next up is our switch. And this one sort of looks like what it is. When it's closed, you have that closed line. And when your switch is open, you have the line flicking up, creating a gap in your circuit. Here is our cell. That is something that powers our circuit. And when you put two or more cells together, that's what we call a battery. Now, I've got a pretty tenuous link to help you remember this one. So, the positive side of your cell is longer than the negative side of your cell. So you can think about the fact that the positive side is long enough that you could break it in two and make it into a plus sign. Yeah, I mean, I warned you, it was pretty tenuous. Okay, next on our list is a resistor. That is a component that restricts current. And that is quite simply a rectangle. Resistor, rectangle, R. I tried. Okay, and if you want a variable resistor, then you just shove an arrow on it to show that you can vary the resistance of that component. A diode, now this is a component that lets current only flow in one direction. If you know, you know. And that's why it looks like a bit of an arrowhead, where the way the arrow is pointing shows the direction of the current. If you have an LED, that is a light emitting diode, then you have exactly the same symbol, but to show that there is light coming off of your diode, we add two arrows to it like this. Okay, that leads me to the LDR. This is a light dependent resistor. It's a component whose resistance depends on the amount of light that is on it. And similar to our LED, we need to put two arrows onto a resistor to make it a light dependent resistor. But this time we put our arrows pointing downwards onto our resistor. That is because the light is falling on our resistor rather than being emitted by our resistor. Okay, and the final one we're going to look at today, a thermistor. That is a component, the resistance of the component depends on the temperature of the component. And I'm all out of ideas as to how to remember this one, but it sort of looks like you put a tick. So I filmed this one yesterday and I cannot believe that I forgot about the bulb. That thought literally woke me up in the middle of the night. Really? Yeah. Anyway, here it is, our bulb. Obviously, lights and also heats up a room, and it has the symbol X. Okay, a few things to remember when you are drawing circuit diagrams. Your ammeter should be in series or in line with your components, and your voltmeters should always be drawn in parallel with your components or around your components. Make sure if you're drawing a diode or an LED that you put the arrow in the direction of conventional current flow. Wait, what is conventional current flow? It's the direction that my current flows in, from the positive round to the negative. Also, make sure that your cells are all facing the same direction, like this. They won't deliver the same voltage if they're facing each other, like this. Let's make sure we can spot the difference between a series and a parallel circuit. So in a series circuit, your stuff is all in a line. And in a parallel circuit, there are junctions, and your stuff can exist on different branches. One big difference between a series and parallel circuit is what happens when something breaks. In a series circuit, if any of your components break, the whole circuit turns off. In parallel, that's not a problem. If a component in one branch breaks, none of the other branches are affected. This also means by putting a switch in different branches, you can turn branches on and off individually. There are plenty more differences between series and parallel circuits, but I'm already ready to bore you about those in the next videos. Okay, thanks for watching. Please do continue clicking on the videos to learn more about electricity. Make sure you download the notes.